If you've ever gazed up at the night sky and felt a shiver of awe, or maybe a twinge of existential dread, at just how tiny we are in the grand scheme of things, you're not alone. Space is vast, mysterious, and sometimes a little intimidating. But what if I told you that our place in the universe might be even stranger than you ever imagined? Today we're diving into a cosmic mystery that could change the way you see everything. The possibility that Earth is floating in the middle of a gigantic, almost empty region of space, a cosmic void. And believe it or not, the clues to this mind-bending idea come from the very first moments of the universe, from a sound that echoed across the cosmos nearly 14 billion years ago. So buckle up, because we're about to take a journey from the birth of the universe to the edge of the cosmic abyss, and discover what it really means to be a tiny blue planet in a possibly very lonely neighborhood. Picture this. The universe isn't just a random scattering of stars and galaxies. Instead, it's structured like a vast, intricate web, with dense clusters of galaxies connected by filaments and enormous, almost empty regions in between. These are the cosmic voids. Imagine the universe as a sponge, with the galaxies forming the solid parts and the voids as the holes. Now, recent research suggests that Earth, our solar system, and even our entire galaxy might be sitting right in the middle of one of these gigantic voids. But how did scientists come to suspect this? The answer lies in the faintest whispers of the cosmos, echoes from the dawn of time itself. To understand this cosmic puzzle, let's rewind the clock, way back. Nearly 14 billion years ago, the universe as we know it began with the Big Bang. But forget the idea of a silent explosion in the void. The early universe was anything but quiet. In fact, it was a place of unimaginable energy and chaos, a seething, roiling sea of particles and light. Temperatures soared to trillions of degrees, and matter and energy were packed together so tightly that the laws of physics as we know them barely applied. In those first moments, the universe was a hot, dense plasma, a kind of cosmic soup where particles collided, merged, and split apart in a frenzy of creation and destruction. Imagine the world's loudest pressure cooker, but on a scale so vast it defies comprehension. The early universe was filled with sound. Yes, actual sound waves, though not the kind you or I could hear. These were pressure waves rippling through the hot plasma, compressing and rarefying matter as they traveled. Scientists call these baryon acoustic oscillations, and they were set in motion by the intense energy of the Big Bang itself. These waves shaped the very structure of the universe, leaving behind subtle imprints that we can still detect today. These primordial sound waves were truly colossal. Some stretched across hundreds of millions of light years. As they moved through the early universe, they created regions of higher and lower density, like ripples spreading out from a stone dropped in a pond. Over time, these ripples became the seeds for the vast cosmic structures we see today. Galaxies, clusters, and the immense voids in between. The echoes of these waves are still out there, faint but detectable, woven into the very fabric of space. Fast forward to the present day. Scientists have developed incredibly sensitive instruments, like the Planck and WMAP satellites, to capture the faint afterglow of the Big Bang, known as the Cosmic Microwave Background, or CMB. Think of the CMB as the universe's ultimate baby photo, a snapshot of what the cosmos looked like just 380,000 years after its birth. This ancient light has traveled across the universe for billions of years, carrying with it the imprints of those primordial sound waves. By studying the tiny fluctuations in the CMB, scientists can peer back in time and reconstruct the early history of the universe. But when researchers began to analyze the CMB in detail, they noticed something strange. In certain directions, the expected patterns of sound wave echoes were missing or unusually quiet. It was as if, in some parts of the sky, the universe had gone silent. This cosmic silence puzzled scientists. Was it a fluke, a glitch in the data, or a sign of something much bigger? As they dug deeper, a startling possibility emerged. Maybe the silence was real, and maybe it meant that our corner of the universe is different from the rest. The evidence began to point toward a radical idea. Earth, and the Milky Way galaxy, might be located inside a vast cosmic void, a region of space that's unusually empty, stretching for nearly 2 billion light-years in diameter. To put that in perspective, that's about 20,000 times the size of our own galaxy. In this immense bubble, there are far fewer galaxies, stars, and planets than in the denser regions of the universe. It's like living in a cosmic ghost town, surrounded by emptiness on a scale that's almost impossible to imagine. So what does it mean to live in a galactic ghost town? For one thing, it changes our perspective on the universe. Most of us imagine space as being filled with stars and galaxies, but the truth is, most of the universe is empty. The cosmic web is mostly void, with matter concentrated in thin, thread-like filaments. If we really are in a void, it means our view of the cosmos is shaped by a vast emptiness, and that could have profound implications for how we measure and understand the universe. But why does this matter? Well, the location of Earth within a cosmic void could affect some of the most fundamental measurements in cosmology. For example, scientists use the light from distant supernovae to measure how fast the universe is expanding, a value known as the Hubble constant. But if we're in a region with fewer galaxies and less matter, the expansion rate we observe might be different from the average rate in the rest of the universe. This could help explain why different methods of measuring the Hubble constant have produced conflicting results, a mystery known as the Hubble tension. And it doesn't stop there. The existence of a giant void could also affect our understanding of dark energy, the mysterious force that's causing the universe to accelerate in its expansion. If our measurements are skewed by our location in a void, we might be misinterpreting the true nature of dark energy, or even missing clues about the shape and fate of the universe itself. Some scientists have even suggested that the cosmic void could be a key to solving some of the biggest puzzles in modern physics, from the nature of gravity to the ultimate fate of the cosmos. Of course, not everyone agrees. The idea that we're in a cosmic void is controversial, and the evidence is still being debated. Some researchers argue that the anomalies in the CMB and other data can be explained by more mundane factors, like measurement errors or unaccounted for cosmic dust. Others believe that the void hypothesis is a game changer, one that could force us to rethink everything we thought we knew about the universe. The debate is fierce, with teams of scientists around the world racing to gather more data, refine their models, and test new theories. So what's the truth? Are we cosmic wallflowers, quietly drifting in a lonely patch of space? Or is the universe hiding something even wilder in the silence? The answer may take years, or even decades, to uncover. But one thing is certain: the quest to understand our place in the cosmos is far from over. Every new discovery, every strange anomaly brings us one step closer to unraveling the greatest mysteries of existence. And who knows? Maybe the next big breakthrough will come from someone watching this very video, inspired to look up at the stars and ask, what's really out there? If you're as fascinated by these cosmic mysteries as we are, don't forget to smash that like button, subscribe for more mind-blowing science, and drop your wildest theory in the comments below. Are we living in a cosmic void, or is there something even stranger waiting to be discovered? Let's explore the universe together, one mystery at a time.